You've just received some bad news from your doctor. You've taken a test designed to detect a type of cancer, and it has come back positive, indicating that you have this type of cancer. Toastmaster of the day, fellow Toastmasters and guests, things may not be as dire as they sound. This may not be an existential crisis. The doctor tells you that only 0.1% of the population actually have this type of cancer, and that the test is 95% accurate. But what does that accuracy mean? First of all, there are two types of errors a test can make. A test may incorrectly say that some of the cases are positive when they really aren't. These are called alpha errors, and more commonly called false positives. On the other hand, the test may incorrectly say that some cases are negative when they aren't. These errors are called beta errors, and more commonly called false negatives. Most medical tests in the real world have some of each, false positives and false negatives. And usually, whatever the test maker can do to improve one will hurt the other. But the question is, how big are these errors? In this case, let's say that the test will correctly give a positive result for 99% of those with cancer, so the false negative rate is only 1%. But because it is 95% accurate, this means it will also give a false positive result for 5% of people that don't have cancer. Because the test is 95% accurate, and it is 99% accurate for those with cancer, most doctors will tell a patient who receives a positive test result that there is either a 95% chance or a 99% chance that they have cancer. But these doctors are very wrong. In this case, the problem is hidden in the false positives and how it compares with the general population with the disease. On average, of 1,000 people that get this test, only about 1 will actually have cancer, 0.1%, and the test will likely correctly report it. But the test will also tell about 50 of the 1,000 that they have cancer. That is 5% of the 1,000 people taking the test. That is, on average, out of 1,000 people that take the test will tell 51 people that they have cancer, but only 1 of those 51 actually do. The chances are much greater that you are one of the 50 people who get a false positive. While it may seem hard to believe, with these numbers, which are quite reasonable, if the test tells you that you have cancer, there is really only a 2% chance that you actually have cancer. And that is from a test that is 95% accurate. This happens dramatically like this when the chance of getting an incorrect result is much higher than the chance of actually having the disease. In this case, it is a 5% chance of getting an incorrect result and only a 0.1% chance of having the disease. I made up these numbers to show in this example. In the real world, the tests should be more accurate, but the principle would still apply. While the numbers are a little different, the same general principle applies to mammography, and is why this practice is being called into question recently by some in the medical profession, especially for women under 50. Many women receive false positive test results and are understandably scared by them. And the doctors, who are not experts in statistics, incorrectly reason that the tests are mostly accurate and recommend treatment rather than perform further tests or even no treatment. This can apply to many other fields as well. I've often suspected that the two phases of testing for computer software are related. The initial, or alpha testing, is testing to make sure the software does what it is supposed to do. After that, the beta testing, often done by potential customers, make sure that the software doesn't do things it isn't supposed to do. In our legal system, ideally, we would never punish or imprison someone who is innocent. But how can we do that? One way would be to declare everyone innocent. That is practically the only way to guarantee that no innocent person is declared guilty. But this solution is also not practical. It definitely lowers the false positive rate, but it does so by increasing the false negative rate to 100%. We still want to punish the guilty. So our test in this case, our legal system, we would like to be as accurate as possible. Because we would like to minimize the false positives, the innocent people declared guilty, we tend to raise the false negatives, those guilty people who are not punished. And now you know the issue with errors that come from tests. Toastmaster of the day.